If you have watched my last two videos, you have installed Docker and you have run your first container. And I know exactly what happened after that. You ran the command, you saw some text, and you thought, okay, but what did I actually just do? Today, we fix that. By the end of this video, you will run a real website on your computer, not a hello world, but a real web server. And then you will run a second copy of the same website at the same time. Then I am going to go inside that website and change it. And then I am going to delete it and show you something that confuses almost every beginner. So without wasting any further time, let's get started. Before we touch the keyboard, I want to explain one idea. If you get this one idea, everything else in Docker becomes easy. So the idea is image and container are two different things. People mix these two up all the time. So let me explain it with food. Imagine a recipe for biryani written on paper. The recipe is not food. You cannot eat a recipe. It is just instructions. Rice, water, spices, cook for this many minutes. Now you follow that recipe and you cook. What comes out? A plate of biryani that you can eat. The recipe is the image. The plate of food is the container. Say that again in your head. Recipe is the image, plate of food is the container. Now think about what this means. One recipe can make many plates. You can cook the same recipe 10 times and get 10 plates of food. Same recipe, 10 different plates. In Docker, it is exactly the same. One image can make many containers, same image, many running copies. Second thing, if you put extra salt on your plate, does the recipe change? No, right? The recipe on paper is still the same, only your plate has extra salt. Remember that extra salt on the plate does not change the recipe. We are going to see that live today, and it is going to surprise you. And third thing, when you finish eating, the plate is empty. You throw it away, but the recipe is still there. You can cook it again tomorrow. So, the image is the instructions. It sits on your disk. It does not run. It does not change. The container is the image actually running. It is alive. You can go inside it. You can break it. You can throw it away. That's it. This is the whole idea. Now let's do it for real. First, let's make sure Docker is running. To check Docker version, type docker hyphen hyphen version. If you see a version number, good, Docker is installed. Now let's run one more command. Docker space info. That is a lot of text and you don't need to worry about it. We only care about one thing. It did not give any error. If you got a big red error saying cannot connect to Docker daemon, that means Docker desktop is not running. Open Docker desktop, wait for it to start and try again. Okay, now let's download our first real image. We are going to use something called nginx. Nginx is a web server. That means it is a program whose job is to show web pages to people. It is used by millions of real websites. Very famous, very common. To download the image, we say docker space pull space nginx. Look at what is happening. You see many lines, each with its own progress bar. That is because an image is not one single file. It is made of layers, small pieces stacked on top of each other. Do not worry about layers today. We have a full video coming on that later in this series. Just notice many pieces downloading together. Done. It says downloaded. Now, where did it go? Let's look at our images. For this, we run docker space images. There it is, nginx. Small note, depending on which Docker version you have, this table might look a little different from mine. Some versions show a column called size. Mine shows disk usage and content size. That is fine. Same thing, just written differently. Do not panic if your screen is not identical to mine. Now here is the important part. This image is not running. Nothing is happening right now. This is just the recipe sitting on your disk. Let me prove it. Let's type docker space ps. Well, docker ps shows you running containers. And look, it is empty. That means nothing is running. We have the recipe. We have not cooked anything yet. Now, let's run your first real container. Type docker space run space hyphen d space hyphen p space 8080 column 80 space hyphen hyphen name web1 and nginx. Wait, do not press enter yet. Let me explain every single part of this because this is the most important command in the whole video. Docker run. This means take an image and make a container out of it. Cook the recipe. Hyphen D. This means detached, in simple words, run it in the background. Without this, the web server would take over your terminal and you could not type anything else. With hyphen D, it runs quietly in the background and gives you your terminal back. Hyphen P 8080 column 80. This is the one that confuses everyone, so listen carefully. A container is like a closed box. Nothing goes in, nothing comes out. By default, even if a web server is running inside it, you cannot reach it from your browser. Hyphen P opens a door in that box. There are two numbers 8080 column 80. The number on the right 80 is the port inside the container. That is where nginx is listening. Nginx always listens on 80. We did not choose that, nginx chose that. The number on the left 8080 is the port on your Mac or on your machine. That is the number you will type in your browser. We chose 8080 ourselves. So the full meaning is anything that comes to port 8080 on my Mac sends it inside the container to port 80. An easy way to remember. Left is my computer, right is inside the container. Left is outside, right is inside. Hyphen hyphen name web1. This gives our container a name. If we do not give a name, Docker makes up a random funny name for you. Names are easier to work with, so let's always give one. And finally, nginx, which tells us which image to use, which is the recipe too. Okay, now press enter. You get a long line of random letters and numbers. This is the container ID. You can ignore it, We gave it a name. So we will use the name. Now let's look. Type docker space ps. And now the table is not empty. There is our container, name web1, image nginx, status says up, and how many seconds it has been running. And on the right, you can see the ports showing 8080 going to 80. Our recipe is now a plate of food. It is alive. Now the fun part. Open your browser, go to localhost column 8080, and there is it. Welcome to nginx. Stop for 1 second and think about what just happened. You did not install nginx. You did not configure anything. You did not edit any file. You typed one line and a real working web server is running on your machine. That is Docker. That is the whole point of it. Now remember what I said about the recipe. One recipe, many plates. Let's prove it. Let's cook the same recipe again. Type docker run -d -p 8081 column 80 name web2 nginx. Look at what I changed. Only two things. The port on the left is now 8081 instead of 8080. It has to be different because 8080 is already taken by web1. Two things cannot use the same door on your Mac. And the name is web2 instead of web1. Names must also be different. Everything else is the same image. It did not downloaded anything this time. It was instant because we already have the recipe. We are just cooking again. Let's type docker space ps. Two containers, both running, both from the same one image. Let's check. First tab, localhost column 8080, still working. Second tab, localhost 8081, also working. Two separate web servers running at the same time from one image. Now let's do something that feels a bit like magic. Let's go inside the container. Yes, you can walk inside a running container and look around like it is a small separate computer. For this, run docker space exec space -it space web1 space bash. Quick explanation. Exec means run a command inside a container that is already running. -it, two letters joined together. It means let me type and see the response. Without this, you would go inside, but you could not interact with anything. Just remember -it when you want to go inside. Web1, it tells which container, and bash is a shell. It is the thing that lets you type commands. Same idea as your terminal. Press enter. Look at the prompt. It changed. It is not your Mac's prompt anymore. It says root at the rate and then some random letters. Now you are inside the container. You are not on your Mac anymore. Let's look around. Let's type ls. Look at this. Bin, etc, home, usr, war. This looks like a Linux computer because it is one. A very small Linux living inside of your Mac. Let's check who we are. Let's type who am I. root. That means full admin power. Inside this container, we can do anything. Now let's find the web page. nginx keep its web pages in one specific folder. Let's type cd. Let's go into user share nginx html. Press enter. Now let's run ls. You'll see some files. The one we care about is index.html. This is the page you saw in the browser. Now let's read it. Cat space index.html. There is the welcome to nginx page. This is the file the browser was showing you. Now let's change it. Let's run echo create header. Inside of it, let's write hello from systems and signals, or you can type your own message and send it to index.html. No output. That is normal. In Linux, when a command works fine, it usually says nothing. Quick explanation of what I did. Echo prints text. The arrow greater than means instead of printing it on screen, put it into this file. And because the file already existed, it wiped the old content and put ours in. Let's check. Let's run cat space index.html again. Now you'll see the whole file is R1 line. Now let's get out. Type exit. Prompt is back to normal. We are out. We are on our Mac again. Let's now go to the browser again and refresh the page. There it is. We changed it. Now, and this is the part I want you to really watch. Go to the other tab, localhost 8081. Refresh it. It still says welcome to nginx. We changed one container. The other container did not change at all. Remember the food? We put extra salt on one plate. The other plate is untouched. They are separate, completely separate. Now, here is the part that trips up almost every beginner. Watch closely. First, a small test. Let's stop the container and start it again. Let's type docker stop web1. The container is stopped. Now let's start that container again. Now let's go to our browser and refresh localhost 8080. You will be able to see that our change is still there. Good. Stopping and starting does not lose your work. But now, let's actually delete the container. Let's type docker space rm space -f space web1. Rm means remove, -f means force. That means do it even though it's running. That container is gone now. Deleted. Now let's make a brand new one from the same image. Let's type docker run -d -p 8080 column 80 -name. Let's name it web3 and use the same image nginx. Press enter. Same image, same port, new name web3 because web1 is gone. Now refresh the browser. Our change is gone. Back to welcome to nginx. Everything we did inside the container has disappeared. And this is the lesson of today's video. So let me say it clearly. When you change something inside a container, the image does not change. We threw away the plate. We cooked a fresh one from the same recipe, and the recipe never had our extra salt in it. Let me prove the image is untouched. Let's run Docker space images. You'll be able to see same nginx image, same ID. Nothing changed about it. It was never changed, and it cannot change. That is the point of an image. So now you should be asking me a question, a very good question. If changes inside a container disappear when I delete it, then how do I make my own website? How do I build something that actually stays? And that is exactly what the next video is about. Before we finish, let's clean up. Containers use memory even when you forget about them. So it is a good habit. So let's first check all the containers, including stopped ones. Let's type docker ps -a. Note the hyphen a. Plain docker -ps shows only running containers. Docker ps -a shows all of them, including stopped ones. A lot of beginners think their containers vanished when actually they just stopped and hiding. So always remember -a. Now let's remove R's. Let's type docker rm-f web2 and web3. You can list many names in one go. Now you can see both are gone. Let's verify it again. Docker ps-a. Now it's gone. Everything is clean. And notice our image is still there. Let's type docker images. Recipe stays, plates are gone. Exactly like we said at the start. So, quick recap of today. An image is the instructions. It sits on disk. It never changes. A container is that image running. It is alive. You can go inside it, and when you delete it, everything you did inside it goes with it. One image can make as many containers as you want, and they do not affect each other. And -p 8080 column 80, left number is your computer, right number is inside the container. In the next video, we solve the problem we just hit. We are going to build our own image, your own recipe with your own website baked into it so it never disappears. This is called a Docker file, and it is where Docker really starts to get fun. If this made sense, subscribe so you get the next one. And if any part was confusing, tell me in the comments. I read all of them and I will explain it. I'll see you in the next one.